Good day, everyone, once again, and you are welcome to Odibra Academy channel. Um, the last time I made video, as usual, when I make videos, I get questions from people in my DM or in the comment section sometimes on problems they are facing in science courses. So the last video I made was about radioactivity, and I've received multiple of questions from that same radioactivity calculation. So to start with, I have two questions that are very important questions, and this question, if you study it very well, is going to pave way for you to solve other questions. So I gave three formulas concerning radioactivity in the last video, and the three formulas are: number one, I said these three formulas, apart from the transmutation, the nuclear equation that I explained, I gave formulas, just three, that will be useful for any calculation in radioactivity. Number one, I said it is very important to know that all these radioactive substances, they have a particular time in which they exist for half of their mass or half of that sample to disintegrate. That means if this marker, as it is now, is a radioactive substance, there is a particular number of years or seconds or minutes, or let me say time generally, that this marker will be expected to disintegrate. Half of it. Half of it will just disintegrate. The remaining half will also spend that same time for half of the remaining one to also disintegrate. And it continues like that. That time required for that substance, for its half, rather, for the half of the substance to disintegrate is what we refer to as half-life. So half-life, decay constant, initial mass of sample, final mass of sample, those parameters are what we look at in radioactivity. So number one, I said you have T half, which represents half-life, is equals to 0.693 over lambda. That is the first formula that is important. The second one that is also important is for you to calculate activity, which is like you are calculating the rate at which that substance is decaying. Activity, which is also dn over dt. Sometimes you see in textbook as dn over dt. It is calculated using lambda n. This lambda represents decay constant, while this n here represents final amount of sample remaining. Now the third one we have nt over n naught to be equals to e raised to power minus lambda t. Now, there is difference between this t and this t. This t here represents time taken. This t here represents half-life. So there is a clear difference between the two. In questions, if you are not very careful, you can easily mistake time taken for half-life. Whenever half-life is given, it will be mentioned that half of that substance disintegrates or half of that substance decay in so time. That is explaining half-life. It takes also time for this to react. That is time taking. Or what is time taking for this substance to remain to this? That is time taking. But whenever half is mentioned, that half of that substance disintegrate or decay, or it takes also time for this substance, for half of this substance to goes away, then they're talking about half-life. So other parameters here, this n naught represents initial amount of sample, n naught. This one is final amount of sample. This E is just exponential, is constant, while this is representing decay constant, like I said earlier. Decay constant, and this is time taking. Time taking. So these three formulas are very important as far as radioactivity is concerned. So I'll be using two questions to explain, or I will using these three formulas to explain the two questions that I got in my DM. The first question is that the radioisotope cobalt 60 again, cobalt 60 is used to destroy cancerous cells by directing gamma rays into the cancerous cell tissue. Calculate the fraction and percentage of a cobalt 60 sample left after 25 years. That 25 years is our small letter t, which is time taken. 25 years. Half-life is 5.27 years. That means our T half is equals to 5.27 years. That's half-life. So we are asked to calculate fraction and percentage of cobalt 60 left after 25 years. Now, fraction or percentage left. If you are asked to calculate fraction left or fraction remaining, it is always given as nt over n naught. This represents fraction remaining or fraction left after a particular time. Now it means you are calculating this, and if you don't forget from the formula I gave, this is equals to e raised to power minus lambda t. Now it means what we want to calculate now requires for us to know our lambda and our time taken. Thank God, time taken has already been given in the question, but our lambda is not given yet. Now we can get lambda from saying T half is equals to 0.693 over lambda, or lambda itself is equals to 0.693 divided by T half, which will give us 0.693 divided by our T half is already given in the question to be 5.27 years. So lambda is going to give us at the end of the day to be equals to, you press your calculator very well, you have 0.1315 per years. That's the unit of lambda. It can be per second, it can be per minute, per hour, but this time around it is per years. Now we have our lambda, and thank God we have t in the question. So this now, continuing from this place, is equals to e raised to power minus, our lambda is already 0.1315, 0.1315 multiplied by our t is 25. So what would this give us? We're going to have fraction now to be equals to 0.03735. If you press this in your calculator, you can press shift of lane. There's lane on your calculator. Shift of lane raised to power minus 0.1315 multiplied by 25 is going to give you 0.03735. So this is the fraction left after 25 years. So to calculate percentage, just say that percentage of fraction left after 25 years is equals to 0.03735 multiplied by 100, which is equals to 3.735%. That means that sample reduced from 100 to 3.735% in 25 years. So that's for the first question. For the second question, the half-life of cesium is 9 hours. That means we have T half to be equals to 9 hours. How much of sample of 10 gram, that means our N naught, is equals to 10 gram. How much of sample of 10 gram will decay after 2 days? Our T is equals to 2 days. It is advisable for us to convert T in days to hours, because our T half is already in hours, or you convert hours to days. But the easier one is for us to convert days to hours. Just multiply by 24 hours, because for a day we have 24 hours. For 2 days we are going to have 48 hours. So for us to calculate the part that decayed, what is the amount of this 10 gram that decayed? Now, the difference between amount that decay, initial amount, and amount left. If you have, for instance, now 100 naira before going to a shop to purchase something, And after you left the shop, you have 10 naira with you. That means you have spent 90 naira. This 90 naira is the amount that decayed as far as radioactivity is concerned. This 100 naira is the initial amount, N naught, and this 10 naira is the final amount, NT. So you agree with me that to get amount that decayed now, mathematically will be equals to initial, which is N naught, minus NT, which is final. And that is going to give us 100 minus 10, which is 90. That's it. So to contextualize now in this question, to get decayed now in this question, we have decayed amount to be equals to 10 minus NT. So we are going to calculate NT. To get NT now, from our formula of NT divided by N naught equals e raised to power minus lambda t. So we can rewrite this to be NT is equals to N naught multiplied by e raised to power minus lambda t. Now, t has already been given in the question to be 48 hours, but lambda is not given. Thank God we're given t half, we can get our lambda from there. So lambda now is equals to t 0.693 divided by t half. Our t half is given to be 9 hours. So it's equals to 0.693 divided by 9 hours. And that will give us 0.077 per hour. 0.077, that's our lambda. So we can just input here that our NT now is equals to N naught, which is already given to be 10. 10, let me erase this so that it will not be confusing. 10 multiplied by e raised to power minus our lambda has already been gotten to be 0.077 multiplied by our t, which is 48 hours. 48. So finally, our NT, if you do your calculation very well, NT will be equals to 0.248. 0.248 gram. That means after 48 hours, it has decreased from 10 to 0.248. So the amount decayed will be equals to, like I said, that it is 10 minus NT, or let's say N naught minus NT, but we have our N naught to be 10. So to be 10 minus 0.248, which is equals to 9.752 grams. So after 48 hours, 9.752 gram of 10 gram has decayed. So that's just to calculate questions that involve radioactivity. It's very simple. Just know those parameters and know what each parameter represents. Kindly drop more questions in the comment section, and you can also recommend topics in which you want me to make videos on. It is not only chemistry. You can go to physics, biology, and some part of biochemistry. Thank you.